Okay, so today's topic is limiting reagent, and just like the bell work, it's the same idea. So you're given 15 bike frames and 26 tires. How many bikes can you make? Okay, so the way I approach this problem is say, hey, if I use all my bicycle frames, I'll make 15 bikes. If I use all my tires, I'll only make 13 bikes. I don't have enough parts to make 15 bikes, so I'm only going to get 13. Does that sound logical? Well, the same thing happens in a chemical reaction. It has two reactants. If there's two reactants and they tell you about both of them, you don't know which one you're going to run out of first. And once you run out of one of them, everything stops. You stop making bicycles when you ran out of tires. You're going to stop making chemicals when you run out of one of the reactants. That reactant you run out of is called the limiting reagent. Reagent is another name for reactant. So the limiting reactant, the reactant that limits how much you can make. So when you're making your bicycles, how many parts are left over? Okay, well, what's left over is frames. And if I use up all my tires, I'll use 13 frames. And I had 15 frames, so I'll have 2 frames left. Does that make sense? So I took the one I ran out of tires, turned it into one I didn't run out of, frames. Said, if I use up all my tires, I will need this many frames. I subtract that from how many I started with. I started with 15, I used 13, I have 2 left. That is how you figure out the excess reagent. Excess, more than you need. Extra. So, if you have 2 reactants, unless they're mixed perfectly, you've got limiting and excess reagent. You're going to run out of one before you run out of the other. If you happen to have them mixed perfectly, it's called a stoichiometric mixture. So, everybody can figure it out with bikes? The math's pretty easy? Well, the same math applies to chemicals. Okay? We're not going to do any different math. We're going to figure out how much we can make twice and figure out which one makes the less. So you're not going to be able to do it in your head. You're going to have to do stoichiometry problems. So you do 2 stoichiometry problems and turn them into the same reactant. Or say same product. So not reactant, product. And the one that makes the least product is the limiting reagent. So you turn them both to product, and whichever one makes the least is the limiting reagent. So we're not going to do any different math. We may have to do it twice, but it's not different. Same math we've been doing. So copper 1 sulfide, so copper reacts with sulfur to form copper 1 sulfide. If 10.6 grams of copper reacts with 3.83 grams of sulfur, how much product will be formed? This is different than all the problems we've done before because they told you about two different reactants, copper and sulfur. Just like the bicycle example, they told you how many pieces you started with. So, what's the balanced equation? Copper plus sulfur makes copper 1 sulfide. Copper's 1 plus, sulfur's 2 minus. Crisscross, get Cu2S. Balance by putting a 2 in front of copper. And I start off with my 10.6 grams of copper. I'm going to take those grams of copper and turn it into moles of copper. Then moles of copper I'll be able to turn into moles of product. There's only one product here. If it makes more than one product, choose one and do both the same for both. Got to see how many of the same product you're making. And my balanced equation was 1 mole of copper, 1 sulfide for every 2 moles of copper. And then I can take my mole of copper, 1 sulfide and turn it into grams of copper, 1 sulfide. And I get 13.3 grams of copper, 1 sulfide. So I circle that answer and I walk away. No. That's how much if I use up all the copper. Are you sure I'm going to run out of copper first? No. So I got to do the same process with the sulfur. So I take that 33.83 grams of sulfur, change grams of sulfur to moles of sulfur. Then change the moles of sulfur into moles of copper 1 sulfide, the same product. And then take the moles of copper 1 sulfide and turn them into grams of copper 1 sulfide like above. And if you type those buttons on your calculator, you'll get 19.0 grams of copper 1 sulfide. So how much do I make? 5.7, the difference between those two. 13.3, 19.0, or 32.3. So think about the bike examples. If I use up my tires, I can make 13 bikes. If I use up my frames, I can make 15 bikes. So I can make 28 bikes. That doesn't work, does it? So the answer is the smaller number. Say, well, Mr. Green, I did 2 problems. Math class tells me if I got 2 equations, I get 2 answers. Well, here's the other answer you get. Not only did you learn that you're going to make 13.3 grams of copper 1 sulfide, you also learned that copper was a limiting reagent. Okay? See how there's different answers. One of them is what you run out of. I run out of copper. Then everything stops. So the right answer is the one that's smaller. No. You need to indicate somehow that is the answer you've chosen. Okay, so that's not too bad. Do 2 problems, whichever makes the least, that's how much you get. Tells you what you're going to run out of. slightly more challenging. How much excess remains? I did not run out of sulfur. I ran out of copper. So I've got some extra sulfur left over. Okay. Use the limiting reagent to figure out how much excess reagent you used. When I ran out of frames, I had used, when I ran out of tires, I'd used 13 frames. Ran out of tires, I'd used 13 frames. Okay? Then I have to subtract that from the amount I started with. I started with 15 frames. I subtract 13, I have 2 left. So let's do that with the last problem. What did I run out of? Copper. So I start off with the thing I ran out of, 10.6 grams of copper. Change grams of copper into moles of copper, because I want to talk about the reaction. 1 mole is 63.55. If I want to talk about the reaction, I got to be in moles. Then change moles of copper. So I took the limiting reagent and I'm going to turn it into the excess reagent. In our balanced equation, the Cu had a 2 in front of it, the S had a 1. And then change the moles of sulfur into grams of sulfur. So I'm turning one reactant into the other. And when I push those buttons, 10.6 divided by 63.55 divided by 2 times 32.07 equals 2.67 grams of sulfur. How much sulfur did I start with? How much sulfur did I start with? I started off with 3.83 grams. So I took 3.83 grams of sulfur to start, minus the 2.67 grams of sulfur, leaves me with 1.16 grams of sulfur left over. So I took what I started with, minus what I used, and that equals leftover. So the stoichiometry part is still the same. You just got to decide what you're going to turn into what. So you start off by taking both reactants and turn them into a product to let you know which one you run out of and how much stuff you're going to make. Then you take the one you run out of and turn it into the one you don't run out of to figure out how much you used, so you can subtract that from the total. Does that make sense? Because there was only one product, there was a different way to do this. Say, what do you mean there was a different way to do this? Okay. Well, I know that I made 13.3 grams of copper 1 sulfide, right? And I used and I started off with 10.6 grams of copper. So if I just subtract those, 13.3 grams of copper out of 30.3 with copper 1 sulfide minus 10.6 grams of copper, that leaves me with 2.7 grams of copper, grams of sulfur that I used. You lost a sig fig though, because I had 2.67 when I did the conversion factor. But that only works because it only made one product, so I can say how heavy the product was. We can use that law of conservation mass along the way.
So you're okay with that?
As long as you show me what you did. Okay, so magnesium is put into hydrochloric acid. If 4.87 moles of magnesium and 9.84 moles of HCl are reacted, how many moles of gas will be produced? You don't always have to go to grams, whatever unit they ask you about. Don't always have to start with grams, whatever the unit they start you with. The first step you're going to have to do is recognize that it's a limiting reagent problem. The way you recognize that is they told me about magnesium, one reactant, and HCl, the other reactant. They tell me about both reactants, I don't know which one I'm going to run out of. That was why the ones that had two reactants on the homework a couple times I had to put and with excess. Because you've got to know which one you're running out of. So here, what's the limiting reagent? You have to see, you can't just look at the numbers. So 4.87 moles of magnesium. And I want to get rid of moles of magnesium and turn it into a product. Which product should I pick? I should pick H2 because it said moles of gas. So I'm going to pick the H2. And that's 1 and 1. I can do that without a calculator. 4.87 moles of H2. Then 9.84 moles of HCl. Get rid of moles of HCl. Turn it to moles of the same product, H2. My balanced equation, the H2 has a 1, the HCl has a 2. So that is 5.92 moles of H2. So we've done all the math. What's the answer? The question is, what is the limiting reagent? What did I run out of? Sorry, 4.92, sorry. 4.92. But, well, it doesn't change it anyway. What do I run out of? What do I run out of? Well, which makes the smaller amount? The magnesium, right? So my limiting reagent is magnesium. And I'm going to make 4.87 moles of H2. How much excess remains? So I start with the magnesium. I start with the limiting reagent. Once I find out what the limiting reagent is, I like to start there because it controls everything. And I'm going to change the moles of magnesium into moles of the other reactant. So 2 moles of HCl for 1 mole of Mg, and that is 9.74 moles of HCl. 4.87 times 2. And then from that I subtract I take 9.84 moles of HCl that I started with, subtract the 9.74 moles that I used, and I'm left with 0.10 moles of HCl left over. Yeah.
So for the previous question, you were saying why we went to H2 is because it was asking how much.
Average gas, yeah. That would be the clue. If they don't specify which one they want, you can pick either. So sometimes it helps to read ahead in the question to see what they're going to ask you for at the end. Does that make sense? So you can pick, if there's two, you can pick either one, but you got to pick the same one twice. Okay? So that you can make the comparison. And this is about as nasty as I could make it. So where should I begin? Oh, maybe at the beginning. No. Write a balanced equation. Silver nitrate. Nitrate's 1 minus, silver's always 1 plus, so that's okay for silver nitrate. Magnesium chloride, Mg2 plus, Cl1 minus, MgCl2. On a type of reaction, double replacement. So the Ag is going to end up next to the Cl, and the Mg is going to end up next to the NO3. Ag is 1 plus, Cl is 1 minus, that's okay. Mg is 2 plus, NO3 is 1 minus, so I need 2 of those. So to balance it, I got 2 chlorines, got to put a 2 in front of silver chloride, which gives me 2 silvers, so I got to put a 2 in front of silver nitrate, which is balanced. So I take the 5 grams of silver nitrate, change the grams of silver nitrate into moles of silver nitrate. 1 mole is 107.87 plus 14.01 plus 48 is 169.88 grams. Moles of silver nitrate to moles of product. Silver chloride, it's 1 and 1. And then moles of silver chloride to grams of silver chloride. 1 mole is 107.87 plus 35.45 is 143. Oh, nope, you're right. There's 2 and 2. Sorry, 2 and 2. It's 1 and 1. Just 2 and 2. So, 143.32. 143.32. Answer divided by 169.88 times 5. And I get 4.21 grams of silver chloride. Is that my answer? Well, maybe. Got a 50% chance. Ever see it's got a 50-50 chance? I take the 5 grams of magnesium chloride. So 24.31 plus 70.90 is 95.21 grams of magnesium chloride to moles of magnesium chloride. Then moles of magnesium chloride to moles of silver chloride. Same product. 2 and 1. And the last one's going to be the same, 143.32 grams of silver chloride for each mole of silver chloride. And I get 15.1. Yeah, 2 sig figs, so 15. Yeah, 15. So what's the answer? 4.21 grams of silver chloride. How much silver chloride do I make? Different question. What was the limiting reagent?
Silver nitrate.
Yeah, silver nitrate was the limiting reagent. So one of them is asking about, so if it's asked about limiting reagent, it's asked which reactant limited you. So it should be the name of a reactant. Okay. How much excess remains? So I'm going to start with the 5 grams. We decided it was the silver nitrate, right?
Yes.
Was our limiting reagent. And that was what, 169.88? I changed slides, so I have to use in my memory. Then change moles of silver nitrate into moles of the other reactant, magnesium chloride. And that was 2 silver nitrates for 1 magnesium chloride. Then change the moles of magnesium chloride to grams of magnesium chloride. And 1 mole was 95.21 grams. Yeah, the 4.21 should only have 2 as well. .4 grams of magnesium chloride. You circle that because you're going to be tempted to, and it's the wrong answer. That's how much magnesium chloride I used when I ran out of silver nitrate. I started with 5 grams. So 5 grams minus 1.4 grams is 3.6 grams left over. Hey, if you read the book, it does it completely different way. Okay, it would do the bicycle thing like this. The correct ratio in the bicycle is 2 tires for every frame. We had 26 tires for 15 frames. You divide those numbers. You get 1.73. That is less than 2 to 1. That tells me my top number is too small. So I'm going to run out of tires. So they have you take the 2 reactants, get them to and compare them to each other, and then compare to the mole ratio in the equation. So you'd find moles of tires, moles of frames, moles of one chemical, moles of the other chemical. Put them over top of each other and see how it compares to the mole ratio. It works perfectly, but it saves you no time. Okay? So if you want to do it that way, I'm comfortable grading it. But if you want to do it the book's way, that's fine. But I think it takes you on a place where it's easier to get lost. How much can I make? Turn both of them into how much I can make. The smaller answer is how much I'm getting. Right? So